So we have the base, the collector, and the emitter. If the arrow is towards the base, this means this is the PNP transistor, and if we have a symbol something like this, and the arrow is towards the emitter, something similar like this, base, emitter, and collector, so then it will be an NPN transistor, right? So, and then we have taken a look of the common base configuration, and in the common base configuration we have common base configuration, which is in short it is being written as CB configuration, right? So in common base configuration, the base is common in between input as well as the output. So the input circuit is having the base and emitter circuit, and the output is having the base collector junction. And for the normal operation of the transistor, the junction, which is the emitter base junction, it needs to be forward biased, and the collector base junction needs to be reverse biased. So for the normal operation of the transistor, as we have got two junctions, if you remember, we have, let's suppose we have an NPN transistor, and in this one we say one is emitter. Emitter is basically the heavily doped. Then we have the base, which is lightly doped, and then we have the collector, which is moderately doped, right? So as we have got two junctions, so one is the emitter base junction, in short we write EB, and the other one is we have got the collector base junction, right? So we have the emitter base junction and the collector base junction. Now in case of the normal operation of the transistor, the emitter base junction need to be forward biased and the collector base junction need to be reverse biased. So this is just the review which we have done in the previous lecture. Now today we are going to take a look of the common emitter configuration, right? And in case of common emitter configuration, so we will take a look of the common emitter configuration. Common emitter configuration, right? So in common emitter configuration, this means that we will have emitter which is going to be common in between the input side as well as the output side. So how we are going to do it? So let's see. We are going to take, let's suppose we take the NPN transistor, right? we have the base, we have the collector, and we have the emitter over here, right? So we have the base, the collector, and the emitter, right? And for the normal operation of the transistor, what needs to be done, that the base emitter junction need to be forward bias, right? So for that purpose, what we will do, we will have the biasing something like this, and we call this, we call this we call this VBB, right? And the other side is we have the collector emitter circuit, which is going to be the output side, and in the output side we will have to make the collector base junction reverse bias, right? And we say this is VCC. Are you with me?
Yes, sir.
Right?
Yes, sir.
Okay, Ji. So we have this thing now, common emitter configuration, and in this we have two DC sources. One is for the biasing of base emitter junction, and the other one is for the biasing of the collector base junction, that eventually will make the collector base junction reverse bias, right? So what we have now, if you see, we have the input side as well as we have the output side. So in the input, if we see, we have the current which is flowing over here is, we say, let's suppose this is IB. The current which is flowing over here is, let's suppose this is IC, and the current which is flowing over here is, let's suppose this is IE, right? Now within this circuit we have the input side. If I'm going to just show you, so the dotted thing over here is representing the input side over here, as well as the other dotted one, this is representing the output side, right? Now if we take a look of the input side, so
No, sir.
G, question, is this thing fine?
Yes.
Okay, so with this what we can see, that we have a drop between the base emitter junction. So the drop between the base emitter junction, we can say this is VBE, right? It is VBE. Over here we have the potential drop between the collector emitter junction, which can be taken as VCE, right? And there is another potential between the base collector junction, which can be taken as VCB. Are you with me? Just let me
Yes, sir.
Yes, sir.
VCB, right? So with this, what we can see that at the input side, we have the input current, which is IB, and the input voltage, which is VBE. So what we can do, we can draw the input characteristic curve for the common emitter configuration. Let's see how it is going to be. So we have the input current, and input current is IB, and the input voltage is VBE. For the normal operation of the transistor, the base emitter junction need to be forward bias, right? So how this input characteristic curve will look like? Input characteristic curve, right? So how this will look like? Anybody? Anyone? Are you with me?
Yes, sir.
आपके साथ है पर ड्रा नहीं कर सकते.
जी?
आपके साथ है पर ड्रा नहीं कर सकते.
अच्छा, तो okay. So as you know, the base emitter junction need to be forward biased. So as in the forward bias, the drop across the diode is normally 0.7 volts, right? So this means if we take the practical diode, so it will be something like this, and if we take the piecewise linear model, so it will be something like this, right? So depending upon which specific model we are considering, but normally at 0.7 volt, we say the diode becomes forward bias, and when this becomes forward bias, the potential is being retained at 0.7. So what we can say that the drop across the base emitter junction will be 0.7 volts. Are you with me?
Yes, sir.
Right? So
Yes.
this means at 0.7 volts, we will have a curve something like this, right? Now coming to the output side. So the output side of the common emitter configuration, what we can see that we have the current is IC, and the drop between the two terminals of the transistor is one is the collector, the other one is the emitter. So what we can say, the potential at the output of the common emitter transistor will be VCE, and the current which will be flowing in the output circuit will be IC, right? Now as we are going to draw the characteristic curves, so what we need to do, we need to add some resistances into the circuit so that we should be able to have the retainment, and we should be able to control the amount of current which is flowing in the circuit. जी कलीमुल्लाह हुआ है? जी कलीमुल्लाह जी कलीमुल्लाह
Sir, if we consider the diode as ideal diode, then
जी
curve कैसे होगा उसका sir?
Okay, if the diode is an ideal diode, so in that specific case, if you see the curve over here will be something, we can say the curve is over here, right? So if we consider the diode as an ideal diode, so this means VBE will be equal to 0 volts, and this means the diode will be short circuited, and once the diode will be short circuited, the curve will be somewhere or here, right?
Okay. Yes, sir.
Okay, now coming back to the output side of the transistor. So as we will be working with the voltages and the currents, so what we need to do, we need to make this circuit more practical, and to make this circuit more practical, we need to add the resistances in the circuit. So one resistance over here is being added, and the other resistance here is being added. So the resistance which is being added over here, we can call this as RC, and the resistance which is being added over here, it is being called as RB. Are you with me?
Yes, sir.
Okay, now what we can do, we can apply the Kirchhoff current law in the input, Kirchhoff voltage law KVL at the input side, as well as applying KVL at the output side of the common emitter configuration circuit, right? So if we apply KVL to the input side of the circuit, what we are going to get, let's see. Applying KVL to the input side of the circuit, so this means we will be having it will be VBB will be equal to IB RB plus VBE. Are you with me?
Yes, sir.
And similarly, we can say IB RB is equal to VBB minus VBE, right?
Yes, sir.
Or we can say IB is equal to VBB minus VBE divided by RB, right?
Yes, sir.
Okay, now taking a look of the output side of the circuit is over here. So we can see that VCC should be equal to ICRC plus VCE. Are you with me? So applying KVL to the output side, we are going to have the equation here. Okay, so applying KVL to the output side, we will have the equation VCC should be equal to ICRC plus VCE, right? Or we can say ICRC is equal to VCC minus VCE, right?
Yes, sir.
Or we can say VCE is equal to VCC minus ICRC, right?
Yes, sir.
So both equations, they are valid, right? Now coming towards
सर
J,
ये माइनस वीसीसी नहीं आएगा वो करंट के डायरेक्शन को देखकर पॉजिटिव साइड पर एंटर हो रहा है वोल्टेज सोर्स में
किस तरह J?
वीसीसी में ऊपर सर डायग्राम में ये करंट वीसीसी में पॉजिटिव साइड से एंटर हो रहा है तो ये माइनस वीसीसी नहीं आएगा
कहाँ से पॉजिटिव साइड पे एंटर हो रहा है?
इधर इधर ये वीसीसी में
VCC में कहाँ एंटर हो रहा है? The direction of the current, if you see
केवीएल का डायरेक्शन सर
जी, KVL आप जिस तरह भी रखें, it doesn't matter.
यस सर
The direction of the current IC you can see in the circuit, right?
यस सर
So this means the total VCC is equal to the drop in the RC plus the
यस सर
across
सीई
VCE, right? And from
Yes,
there we go ahead and we have this equation, right? And we can play around with this equation later on, right? ठीक है जी? Are you with me?
Yes, sir.
Okay, so now coming towards the output characteristic curve. So the output current is basically what we have. The output current is IC and the output voltage is VCE, right? Are you with me?
Sir.
Okay, now if we say that the current IB is equal to, if we say IB is equal to 0, right? If we say IB is equal to 0, now what will happen? And what does this mean? If you see,
on the VCC line.
okay, so when IB is equal to 0, if we go back to the circuit, how IB can be equal to 0? This means at this point VBB is 0, right? When VBB is equal to 0, this means the current flowing in the base is 0, right? And when VBB is equal to 0, this means the VBE, the base to emitter voltage, which is not making the transistor base emitter junction forward bias, right? So if the base emitter junction is not forward bias, so this means that we have no current which is flowing in the base of the circuit, right? Are you with me?
No, sir.
No? Okay.
Yes, sir.
Okay, let's take a look again. What we are saying, that if IB is equal to 0, what does this mean? This means that the potential across the base emitter junction is not making it forward bias, and therefore the base current is 0, right? Now this is clear,
Yes, sir.
right? So if the base emitter junction is not forward biased, so this means the base emitter junction is now reverse biased, right?
Yes, sir.
So what we can say, that the condition is something like if I make the transistor again and I say that there is IB is equal to 0 over here, right? So this means we have some current which is flowing over here, and what we say this current over here is ICEO, where ICEO is basically that current which is flowing through collector to emitter junction when the base is open, right? So let's see what is this. So if you remember last time in the common base configuration, we come up with the equation that was equal to IC was equal to alpha times IE plus ICBO. If you remember this, this was the equation
Yes, sir.
we have obtained from the common base configuration, right? Are you with me?
Yes. Yes, sir. Yes, sir.
Okay. If we go further on from here, so we know this thing that IE is equal to IC plus IB, right?
Yes, sir. Sir.
So putting the value of IE in this equation over here, so what we are going to get, IC is equal to alpha times IC plus IB plus ICBO, right? Or what we can say that we will have IC minus alpha times IC is equal to alpha times IB plus ICBO, right? Or I can say IC is equal to alpha divided by 1 minus alpha IB plus ICBO divided by 1 minus alpha. Are you with me?
Yes, sir.
Yes, sir.
Right? Now,
Yes.
in this our case, when we say IB is equal to 0, right? So putting this thing in this equation that IB is equal to 0 over here, so what we are going to get, IC is equal to
0.
ICBO 1 minus alpha, right? Because IB is equal to 0 in the equation. Are you with me? Right?
Yes, sir.
Yes,
Yes,
sir.
So,
sir.
and normally the value of alpha is in between, normally the value of alpha is in between 0.9 to 0.998, which is approximately very close to 1, right? Why? Because alpha is approximately equal to IC by IE, right? And we say that the value of beta is very small, so therefore the value of alpha is approximately equal to 1, right? Are you with me?
No sir, ये repeat करे जरा.
Acha. Okay, alpha is basically the ratio of the IC to IE, right? ठीक है जी. Alpha is the ratio of IC to IE, and as we know from this equation over here, that IE is equal to IC plus IB, but as we know the value of IB is very small, because IB is normally in the range of microamperes and IC is in the range of milliamperes, right? So as micro is very smaller than the milli, so therefore we say that IC is almost equal to IE, and when we say this thing, we say the alpha is approximately equal to 1. But normally the range of alpha is from 0.9 to 0.998, right? So 0.998 can be taken approximately equal to 1, right? And once this is the case, so what we say normally, the in between the range, if we put the value of alpha over here within the range in the equation over here, in this equation, if we put the value over here, so let's suppose we say the value of alpha is 0.996, right? So if we say the value of alpha is 0.996 in this equation, so what we are going to get, we are going to have IC is equal to ICBO 1 minus 0.996, right? And if this is the case, so if you see, it is 1 ICBO divided by 0.004, right? And if you convert it, so this means this will be equal to 250 times ICBO. Are you with me? Now this value over here is representing ICEO, which is the value of the current which is flowing in the collector to emitter circuit when the base is open. So this means the value which we are going to get over here when IB is equal to 0 at the output characteristic curve, the value is over here will be something like this, which is not